Now this is question 4 on slide 3 on the linear motion handout. So I've drawn the graph already. It says the points P and Q lie on a straight level road. So here they are. A car passes point P with a constant speed of 13. So here it is. And continues at this speed for 9 seconds. So I've marked that in here at 9 seconds. The car then accelerates uniformly for 5 seconds to a speed of 28. So this is my acceleration for 5 seconds to a speed of 28. And then it decelerates uniformly from 28 down to rest, all the way down to here at Q. And that car travels 98 metres while decelerating. So I know that bit of a distance. You've got to draw a speed time graph. So this is what you would draw. You'd mark the axis velocity meters per second, time seconds, and sketch motion. Now, first part B says, that's part A is draw the graph. Part B says, find the acceleration. So you've got to find A here. So remember, we're going to do the same as we did last time. I'm going to draw an x-axis like this. I'm going to indicate this angle theta, and I'm going to say that that slope of the line is equal to the tan of theta. So tan of theta is equal to the slope, and of course the slope is equal to acceleration A, so the tan of theta is equal to A, and the tan of theta is opposite over adjacent. So the opposite is this bit here, from 13 to 28, so that's 15, and the adjacent is that base, which is 5. So that means that the acceleration is 3 meters per second squared. Right, so that's the first bit. The second bit says, find the deceleration. So this is my deceleration here. So the deceleration is the slope of that line there. So if I indicate this angle here, I'm going to call this angle maybe alpha, and I'll say that the tan of alpha is equal to the slope. So of course that's the deceleration. So the tan of alpha is of course the opposite over the adjacent again. So what's the opposite over the adjacent this time? Okay, so the opposite is from 0 all the way up to 28 this time. And the adjacent is from here to here. I'm going to call that T. Don't know what that is. So that's the deceleration. And so I've got to find an unknown. I've got T that I don't know. So my next job is to find T. Okay, T belongs to this part of the motion here. So remember, this is the deceleration. This is 28. So this is a triangular shape now. Height is 28. This is T. And we know that the distance covered, which would be the distance under this curve, so to speak, is 98 meters. So the area of that triangle is equal to 98. So the area under the curve, there's your curve, I'll just mark it here in red. So this is your curve. The area under that curve, the area under this is 98. So how did I get the area of a triangle? I say half the base, which is T, by the perpendicular height, 28, that's equal to 98. So that's 14T is equal to 98. That 14 will go into T, how many times? Is it 5? What is it? 98, 14 from 28, 56. Will it go in 5 times? Just, I don't know. Right, more than that. 98 divided by 14 will go in 7 times. So T is 7. So that means my deceleration is 28 over 7, which of course is 4 meters per second squared. Right, second part of the question done. Now, I'm going to use this part of the page next. So that's part 1. Part 2, I'm going to do part 3 over here. So we're going to find the total distance between P and Q for part 3. So PQ. To get from P to Q, you can see that we've got a few different shapes. So I'm going to divide them up into A, B, C, and this bit D, which is 98. So the total distance will be A plus B plus C plus 98. Okay, so what's A? A is a rectangle, 13 by 9. B is another rectangle, 13 by 5. C is a triangle, half the base is 5, by the perpendicular height from 13 to 28 is 15, and D, of course, the last bit is 98. So if I add all that up, what do I get? 13 by 9 will give me 117. 13 by 5 will give me 65. And 15 by 5 will give me 75. And a half of that will be 37.5. And then when I add those four numbers up, so 37.5 plus 65 plus 117 plus 98 gives me total distance of 317.5. So that distance from P to Q is 317.5. Now, the last bit of that question says the average speed of the car as it travels from P to Q. Now, average speed, because the speed is changing, as you can see as we go along. So the average speed is the total distance divided by total time. So we know what the total distance is because we're after finding that. It's 317.5. Now the total time would be 9 plus 5 plus t. So that's 14 plus t. I already know what t is. It's 7. So that's going to be 317.5 divided by 21 gives me an average speed of 15.12 if I round it to 2 decimal places, meters per second.